The second example on this page deals with a shift. And we know we've got a shift because we see this x minus 3 and y plus 2 inside the quantity squared. And that's going to give me my horizontal and vertical shift. But first thing we want to do is we want to first get this into standard form. And remember, to be in standard form, we need this equation equal to 1. So since this is equal to 25, I'm going to divide everything through by 25. So when I do that, 5 over 25 here is going to reduce to 1 over 5, so x minus 3 quantity squared over 5. The second piece right here, 25 divided by 25 is going to be 1. So y plus 2 quantity squared over 1 is equal to 1. There's my ellipse in standard form. Now I can start identifying the different pieces. The center is the opposite of the numbers we see here, or what we plug in for x and y to make those quantities equal to 0. So here I would plug in a 3. The second piece I would have negative 2. So my x portion of my center is 3. My y portion is negative 2. So I'm going to plot that 3 over, negative 2 down. There's my center. Next thing I need to find are my vertices and my foci. We know my vertices come from the denominators of these different fractions. So first of all, when I look at this, is it going to be a horizontal ellipse or a vertical ellipse? And I can see my larger denominators underneath the x portion. So that means it's going to be longer in the x direction. These values down here are squared values. Since we said this is the larger number underneath the x, this is the a squared. So what we'll do for each of these is we take the square root of each. There's going to be my a. The square root over here is just 1, which is going to equal b. So my a value is going to be square root of 5, which is approximately 2.2 if I convert that to a decimal. And remember from what I said at the very top here, that a is the distance from the vertices to the center, or from the center to the vertices. So this a value is telling me I'm going to go 2.2 units from the center, and since this is under the x, I'm going to go in the horizontal direction. So 1, 2, and there's my 0.2, and 1, 2, and there's 0.2. So a little more than 2 units out. That's going to be my vertices. And let me just write those down. Vertices. And to get the exact value, we can leave it as 3 plus square root of 5, negative 2, and then 3 minus square root of 5, negative 2. I'm supposed to put those two values. What I have right here, this is my 3 plus square root of 5 minus 2. And where that comes from is originally this was 3, and I'm adding square root of 5 units out, and then it's 2 units down right here. So this point right here is 3 plus square root of 5 and then negative 2. Going the other direction, that's minus square root of 5. So 3 minus square root of 5, and that was 2 units down. We know in my y direction, the square root of 1 is 1. So I'm 1 unit up from the center. So my ellipse is going to look something like that. The next piece I want are the foci. And we know foci is c squared equals a squared minus b squared. So 5 minus 1. So c squared is 4, so c is plus or minus 2. So that means from the center, I'm going to go 2 units to the right and 2 units to the left. So there are my foci points. And those points are right on the coordinate plane. So 1, negative 2 is one foci, and the other is 5, negative 2. Once again, these values right here come from my original denominators because my original denominators are the squared values. The last piece, eccentricity here, is c divided by a. which is 2 divided by square root of 5, and that's approximately 0.894 for eccentricity. Remember, the closer to 1 we are, the more oval shape we've got. The closer to 0, the more circular it is. Since we're closer to 1 here, it's going to be more oval than, say, something that was 0.251 for an eccentricity. The final piece then is, how would I enter this into my calculator in rectangular form? A couple ways you can go about doing this, but the easiest way is to take your original equation and solve for y. So first thing, if I'm going to solve for y, is I'd move my x quantity to the other side. So 25 minus 5, x minus 3 quantity squared. Then we'll divide both sides by 25. Then we'll take the square root to both sides. And then finally, we're going to subtract 2. So if I were to take the square root to both sides, I'll have plus or minus this whole big mess. 25 minus 5, the quantity x minus 3 quantity squared all over 25, that whole big thing. And then outside of it, we're going to have the minus 2 that we've got to subtract. As you can see, that ellipse in rectangular form is very ugly, and it's got the plus or minus, so it's 2 equations. When we get into the rectangular, the parametric and polar form, the equations get a lot nicer, which is one of the advantages we'll see down the road. But for now, when we're working in rectangular form, we are going to have very messy equations like that.